Our essential standard number one, rationals. Key points, things that you have to remember to be able to do are you need to be able to factor by grouping. Okay, so the factoring will be involved with this standard. Factor by grouping would be something like x cubed minus 6x squared plus, we'll change that, minus 3x plus 18. 4 terms, factor by grouping. Brianna, any idea?
Combine the first two with the last two.
Alright, so we're going to group these two together. We're going to group these two together. And from the first two, what could we factor out? An x squared. And we would have x minus 6. And from the last two? Negative 3, good. And let's see, so we would get, that's going to work. If you're trying to factor by grouping, what you end up with in parentheses at this point has to be the same in order for it to work. We are then factoring the x minus 6 out, leaving us with that x squared minus 3 left over in parentheses. Occasionally this will end up being, say, a difference of perfect squares and will still be factorable. Okay, factor by grouping. If you forget, page 441 in your book, this is sum or difference of perfect cubes. All right. Jessica knew it. So 8x cubed plus 27. Who can factor that? 2x to the third plus 3 to the third. So if you think about it this way, here we're talking about a sum because we are adding, and they're perfect cubes because this has a perfect cube root, that is 2x, and 27 has a perfect cube root, that is 3. Okay, the formula then. Correct, so a cubed plus b cubed, this is in general, you said is a plus b.
And then a squared minus ab.
Perfect.
Plus b squared.
Alright, that's great. So the difficulty, maybe I'll write out the formula for the difference of perfect cubes. This is an a minus b, and the second trinomial is a squared plus ab plus b squared. Okay. The way to remember these formulas, because you do have to know them, is that each only has one subtraction sign. Okay, each of them only has one subtraction sign, and when it's a cubed plus b cubed, you start out with the binomial a plus b. When it's a cubed minus b cubed, you start out with a minus b. So that's how you can remember minus and plus and minus. Okay. Applying that formula to this factoring gives us 2x plus 3. And then the real common mistake here is when people do a squared, they say 2x squared. It's 2 squared x squared. So 4x squared and minus ab and plus b squared. Okay. In addition, when you're doing this, frequently this is a trinomial that you see in the expression that you're trying to simplify. And so what happens is students see this and they try to factor and they spend 10 minutes trying to factor this. That's not factorable. And they think, if I can't factor this, I'm not going to be able to cancel anything else. Know that if you see that, something like this, and it's not factorable, it may be one of the factors from something larger. Okay, factor by grouping and factoring sum or difference of perfect cubes. We talked about domain restrictions. anywhere there is a fraction or a variable in the denominator, you need to look for domain restrictions. And what is something else tricky about this standard? Negative exponents. Back from Algebra 1, you know negative exponents, you flip and make it positive. Okay, but when you get to something crazy like this, what exactly do you do? When you flip that to make a positive, where does it go? And the real common mistake that people make is they recognize that this is being raised to the -2, but they bring it down here. And that's not correct. Real common mistake. We were just talking about this, weren't we? Yeah. Okay. So what happens with this, if we were to take this one step further, the x to the -2 would go underneath the 3. So we would have 3 over x squared. It stays in the big numerator of the big fraction. And this, the 5 times x to the -3, would end up with a 5 and an x to the 3rd down below like that. And then 10x to the -4, 10 over x to the 4th. Okay.
Do you cancel x squared and x squared?
Well, these are not going to cancel. You have to reduce this as well. Okay.
To find an LCD.
Yeah, so I would recommend finding an LCD for the top, which would be
X
6
cubed.
x cubed, cubed plus 5 over x cubed, common denominator. We can now add those together. And down below, 10 over x to the 4th. That's a good question. Okay. So one more step yields 3x plus 5 over x cubed, and 10 over x to the 4th.
You flip it.
Now we can flip it. Now we can multiply by the reciprocal. So we have 3x plus 5 over x cubed times x to the 4th over 10. And now that we've multiplied, this is like in parentheses, there is something to cancel. What is it? X cubed and x to the 4th. What about the 5 and the 10?
You can't do that.
Can't do it. These are such good students. Alright, so this goes to a 1 and this goes to an x. And we could express our final answer as x, 3x plus 5 over 10. Great. And in general, I like you to leave those in factor form, but it's not really important. Okay.